You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. The purpose of reference architectures in cloud security is to provide organizations with reusable blueprints that make design predictable, secure, and auditable. These models are not optional extras or theoretical guidelines. They represent the distilled wisdom of years of experience building secure environments. Without reference architectures, each team might design its own version of identity, logging, or network controls, and the result would be a patchwork of inconsistent practices that cannot scale or withstand audit scrutiny. A reference architecture ensures that the right controls are always in place and that they work together cohesively. For learners preparing for the CCSP, these blueprints illustrate how abstract principles are translated into concrete structures, while for practitioners, they offer a shared playbook that allows large organizations to operate securely and efficiently. A reference architecture itself can be thought of as a standardized template that captures components, interfaces, and control placements for common solutions. Rather than leaving security up to individual interpretation, it documents exactly how to design a system that meets established requirements. Consider the analogy of a standardized building plan for houses in a subdivision. Every builder can adapt the interior features, but the foundation, wiring, and safety systems are consistent and meet code. In cloud environments, reference architectures provide this same assurance, ensuring that designs do not miss critical protections such as centralized identity, encryption, or logging. They bring order to what would otherwise be a chaotic sprawl of custom configurations. One of the most important examples is the landing zone pattern, which creates a secure baseline environment for multi-account or multi-subscription setups. A landing zone is not simply an empty account into which workloads are deployed. It is a pre-engineered environment that already includes guardrails, monitoring, identity integration, and shared services. Logging accounts may be set up to centralize audit data, while standardized networking rules enforce segmentation and control. This prevents the common problem of cloud sprawl, where developers or teams create accounts with inconsistent policies and limited oversight. By beginning with a landing zone, every workload inherits a secure foundation. For the CCSP exam, you should remember that a landing zone is a comprehensive baseline that enforces governance at scale. The hub-and-spoke network pattern is another critical design. This architecture places a central hub at the core of connectivity, where shared services like firewalls, DNS, and security inspection tools reside, and isolates workloads into separate spokes. All traffic between spokes flows through the hub, giving security teams the ability to monitor, filter, and enforce rules consistently. Without this structure, networks can become flat and interconnected, making it easy for an attacker who compromises one workload to move laterally across the environment. Hub and spoke combines efficiency with safety, allowing organizations to centralize controls while preserving isolation. On the exam, scenarios that mention centralized inspection with workload segmentation are directly pointing to this design. Identity reference architectures provide a standardized model for authentication and authorization across all services. These designs show how to integrate external identity providers through federation, how to simplify user access with single sign-on, and how to enforce least privilege policies through centralized authorization. Without such a model, each application or workload might create its own identity system, leading to fragmented directories, weak password reuse, and limited auditability. A reference architecture ensures that access decisions are consistent and traceable across the enterprise. This is vital for both operational security and compliance, since auditors require clear evidence of identity governance. For CCSP candidates, identity blueprints demonstrate the shift from perimeter defenses to identity as the core security boundary. The data reference architecture focuses on how information is stored, protected, and governed as it moves across environments. This blueprint establishes which storage tiers are used for different types of data, defines encryption strategies for information at rest and in transit, and sets out the approved pathways for moving or replicating data. By following this model, organizations avoid ad hoc decisions that could place sensitive data in inappropriate jurisdictions, fail to encrypt backups, or allow uncontrolled transfers. Data reference architectures align technical practices with compliance frameworks, ensuring that information management meets both business needs and legal requirements. For exam preparation, it is crucial to remember that these blueprints are as much about compliance and governance as they are about performance and cost. Observability and logging blueprints standardize how organizations capture, consolidate, and analyze metrics, logs, and traces. Instead of leaving each workload to define its own logging practices, the blueprint routes all telemetry into a central analytics plane, where it can be correlated and examined. This makes detection of threats faster, supports forensic investigation, and simplifies compliance reporting. Without such a model, logs are often inconsistent, incomplete, or scattered, making it nearly impossible to prove that controls are functioning. For the exam, logging and observability patterns highlight the importance of unified visibility across both control plane and data plane activities. Key management reference architectures define how cryptographic material is generated, stored, rotated, and eventually destroyed. These designs specify how services such as key management service and hardware security modules integrate into the environment, ensuring that keys remain under tight governance. Without a clear blueprint, keys may become unmanaged, shared informally, or never rotated, undermining the very encryption systems they are meant to support. For organizations under regulatory oversight, these patterns also provide the evidence needed to demonstrate compliance with encryption standards. In exam scenarios, questions about key custody, rotation, or lifecycle management often reference these structured blueprints. Secrets management patterns complement key management by focusing on the credentials, tokens, and application secrets that services depend on. A secrets management blueprint ensures that such items are never hard-coded into applications, stored in plain text, or left unmanaged in configuration files. Instead, secrets are placed into centralized vaults, rotated automatically, and logged every time they are accessed. This approach reduces one of the most common attack vectors in cloud systems: compromised or exposed credentials. For CCSP learners, the Secrets Management Blueprint highlights the principle that automation, not human discipline alone, must enforce the protection of critical authentication material. Ingress and egress patterns define how traffic flows into and out of a cloud environment, positioning secure gateways, proxies, and web application firewalls at trust boundaries. These blueprints ensure that inbound requests are inspected for threats before reaching workloads, and that outbound traffic is controlled to prevent data exfiltration. Without such controls, workloads may be left directly exposed to the internet or may send sensitive data outside approved channels. Exam questions that ask about trust boundaries, external connectivity, or the placement of WAFs are often referencing these ingress and egress models. API management patterns provide a structured approach to securing the interfaces that applications expose. They enforce strong authentication, limit request rates to prevent denial of service, standardize versioning to avoid unmanaged sprawl, and log usage for monitoring and compliance. APIs are often described as the front doors of modern applications, and without a consistent management pattern, they can become one of the greatest sources of vulnerability. In the exam, scenarios that involve controlling and standardizing access to APIs are testing your knowledge of this design pattern. Service mesh patterns address the challenge of securing communication within distributed, microservices-based environments. These designs enforce mutual TLS between services, use sidecar proxies to manage policies, and provide centralized observability for service-to-service traffic. Without a service mesh, internal communications are often unencrypted and unauthenticated, leaving systems open to exploitation. The service mesh blueprint ensures that zero-trust principles extend inside the application, not just at its perimeter. For CCSP candidates, recognizing that even internal traffic must be protected is a key learning outcome. Workload isolation blueprints prescribe boundaries, whether at the account, namespace, or cluster level, that prevent one workload from affecting another. These designs minimize the blast radius of a compromise, ensuring that failures are contained and recovery is easier. Without isolation, workloads share too much infrastructure, making them vulnerable to cascading effects. Disaster recovery blueprints build on this by defining how workloads replicate, fail over, and meet recovery time and recovery point objectives. Together, these patterns turn resilience from an aspiration into a documented, testable reality. Compliance's code patterns automate governance by encoding policies into machine-readable rules that are enforced continuously. Instead of waiting for periodic audits, these patterns ensure that compliance is embedded into pipelines and checked with every deployment. Infrastructure as code baselines support this by codifying environment builds, using version control and structured workflows to ensure that infrastructure is repeatable and auditable. These blueprints close the loop between governance and automation, ensuring that secure design is both scalable and sustainable. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. A continuous integration and continuous delivery security pattern is one of the most important reference designs for modern organizations. This blueprint embeds security directly into the development pipeline, rather than leaving it as an afterthought. Static code analysis is run automatically with every commit, secret scanners detect accidental exposures, and artifacts are signed to confirm their integrity before being promoted to production. By enforcing these steps in a standardized way, organizations ensure that vulnerabilities are caught early and that only verified code is deployed. Without this pattern, pipelines become highways for untested or compromised software. For CCSP learners, understanding CI/CD security patterns demonstrates how automation can bring governance to the speed of cloud-native development, reducing risk without slowing innovation. Artifact repository patterns provide another structured safeguard. In today's environments, workloads often depend on containers, packages, or shared libraries, and these components must be stored and retrieved securely. A repository blueprint governs container registries, package stores, and the provenance tracking of each artifact. By following the pattern, every build source is verified, every update is logged, and every artifact can be traced back to its origin. This prevents supply chain risks, such as importing tampered images or running software with unknown dependencies. On the exam, artifact repository patterns highlight how reference designs extend security beyond infrastructure into the lifecycle of the software itself. Patch and vulnerability management blueprints bring much-needed order to one of the oldest but most persistent security challenges. This reference architecture defines how systems are scanned for vulnerabilities, how results are prioritized, and what remediation timelines must be met. By using a blueprint, organizations avoid the chaos of ad hoc patching and establish predictable rhythms that align with regulatory expectations. It ensures that patching is not just reactive, but part of a repeatable process embedded into governance. For exam preparation, these blueprints underline that vulnerability management is continuous and that without a structured design, organizations inevitably fall behind. Network segmentation blueprints define zones, routing control, and microsegmentation policies that prevent threats from spreading unchecked. These patterns show where boundaries should be placed, how traffic should be controlled between them, and how visibility should be maintained for auditing. Without such blueprints, organizations risk building flat networks where a single compromise can cascade across workloads. By contrast, a segmentation blueprint minimizes the blast radius of any incident and ensures that monitoring aligns with business-critical trust boundaries. For CCSP candidates, these patterns highlight the principle that strong architectures are built to contain failure, not just prevent it. Zero-trust reference architectures represent one of the most significant shifts in cloud design. These blueprints enforce identity-centric access, continuous verification, and least privilege principles across every layer of the environment. Instead of assuming that once inside a network perimeter everything can be trusted, Zero Trust patterns assume breach and verify each action, each request, and each user. They integrate identity providers, logging, and policy enforcement into a coherent system where trust is never implicit. For exam purposes, zero trust patterns are often the correct choice in scenarios that describe the need for continuous verification across distributed environments. Edge and content delivery blueprints show how content delivery networks and caching can improve performance while maintaining strong security. These patterns define where edge nodes should be placed, how TLS certificates should be managed, and how caching must be configured to avoid serving stale or insecure content. Without such blueprints, organizations risk undermining both security and availability at the network edge. For CCSP learners, edge designs demonstrate that performance optimization must always be paired with robust protection, and exam scenarios often connect CDN use to security as well as efficiency. Serverless reference architectures provide guidance for event-driven workloads that rely on functions rather than servers. These patterns define how event sources are secured, how permission boundaries are enforced, and how functions must be written with least privilege principles in mind. They ensure that ephemeral workloads are still governed by identity, monitoring, and logging controls. Without this reference, serverless applications may sprawl without clear accountability. On the exam, serverless reference patterns highlight that even when infrastructure is abstracted away, security and governance responsibilities remain with the consumer. Container platform blueprints serve as structured guides for environments that use orchestration tools like Kubernetes. These patterns define node hardening, orchestration-level controls, and runtime protections that prevent exploits such as container escape or privilege escalation. They bring order to the complexity of distributed container workloads by documenting how security should be applied consistently at every layer. For CCSP learners, container blueprints reinforce the idea that modern application platforms cannot be secured piecemeal. They require standardized, comprehensive reference designs. Multi-region active-active blueprints provide guidance for organizations that need global resiliency. These patterns describe how workloads can be replicated and synchronized across multiple regions, so that if one fails, another continues seamlessly. They also address the trade-offs of consistency, latency, and regulatory alignment that such designs require. Without a blueprint, organizations may replicate data inconsistently or violate compliance obligations. On the exam, multi-region patterns often appear in questions about designing for both resilience and compliance. Data pipeline blueprints focus on securing extract, transform, and load workflows. These patterns define how access controls, encryption, and logging must be applied to every stage of data movement. By codifying security into the pipeline, organizations prevent leaks, maintain integrity, and prove compliance. For CCSP learners, data pipeline designs highlight that governance must follow data across its entire lifecycle, not only at rest. Monitoring and alerting patterns define how thresholds are set, how runbooks guide responses, and how escalation paths tie directly to service-level objectives. These blueprints prevent alert fatigue by setting meaningful thresholds while ensuring critical events always trigger responses. Without them, monitoring becomes noise rather than insight. For exam preparation, these patterns emphasize that monitoring must be systematic, tied to governance, and reinforced with documented response plans. Cost governance patterns integrate financial stewardship into reference architectures. They embed tagging standards, enforce budgets, and trigger anomaly detection to prevent runaway spending. In cloud, cost is a security issue, since uncontrolled consumption can create both financial and operational instability. Reference blueprints ensure that governance extends beyond technical controls into economic accountability. On the exam, cost governance scenarios highlight that security and efficiency cannot be separated in cloud design. Testing and validation patterns ensure that every deployment is verified before release and every control is checked afterward. They mandate pre-deployment security scanning, automated validation pipelines, and post-deployment control verification. This prevents misconfigurations from reaching production and ensures that governance is continuously enforced. For CCSP learners, testing patterns highlight that resilience comes from discipline, not hope, and that secure design requires ongoing validation. Documentation patterns close the loop by requiring that every decision is recorded, every control is traceable, and every requirement can be mapped to its implementation. These blueprints ensure that architectures are not just secure but also explainable to stakeholders, regulators, and auditors. They create the paper trail that proves accountability and demonstrates maturity. For the exam, documentation patterns often appear in questions about governance and assurance, reminding you that evidence is as important as execution. In summary, reference architectures are not optional diagrams but curated, reusable patterns that accelerate secure delivery and ensure consistency across cloud environments. They cover every layer, from identity and logging to network design, workload isolation, and cost governance. By following them, organizations gain not only secure systems but also the assurance and evidence required for compliance and trust. For CCSP learners, the ability to recognize which reference pattern fits a scenario is key to exam success, while in professional life, using these blueprints is what makes cloud security scalable, auditable, and dependable. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.